안녕하세요. Welcome to Automatic Control Systems lecture. I am Kalyana Veluvolu with the School of Electronics Engineering, Kimpuk National University. I will be teaching you Automatic Control Systems lecture for the semester. So, before we go into the actual content, in this first class, I would like to tell you about all the details about the lecture, its grading, its learning methods and everything about the lecture. So, this is the week 1 part 1 orientation. So, before we go into the lecture, I would like to explain you about what is automatic control systems. So, what is that you can learn from this lecture? So, if the name automatic control systems, if you look at the name, you have three terms. We have automatic, we have control, we have systems. In fact, these three different aspects in this course. The systems, what we are talking in our automatic control systems lecture is the real world applications. When I say real world applications, they are like the car, train, elevator, robot, drone, everything, every engineering system we use is a system. System is something that responds to an input. Even humans, biological, are also systems. However, in this lecture, our systems, our focus is limited to artificial, man-made engineering systems. So, the real engineering systems which we would like to model or analyze the behavior, those systems like train, car, elevator, robot, etc. So, in the first part, I think in the first 4 weeks, we are going to focus on what is systems. We will be learning about how to model the systems. How to model is mathematical modeling. So, we develop models, we try to analyze the systems in the next 4 weeks, and then after the midterm, we actually move to control. So, what is control here is, it is like a way to modify the system behavior. Control exists everywhere. So, the engineering control, we try to control the system, real system, to provide good performance, to provide better performance, to also we also analyze the system to provide much better result. So, once we analyze the system after modeling, then our aim is to improve the system. So, improve its behavior so that it will give you better results. So, if you have a car, we want the car to be better controlled so that the car performance can be good. So, what we do is we try to analyze the behavior and then try to modify the performance so that we can provide a better control. So, control can be automatic or manual control. So, what we learn in automatic control is we try to model the systems and then we try to design controllers to improve its performance. The last stage, the term what we call is automatic. So, the term automatic also refers to automate the control process so that the system can try to modify its behavior itself. Without human intervention, the system can modify its behavior. So, automate the control process so that no human intervention is present. So, if we combine all these three, we get automatic control systems. So, students, by finishing this course, they will be able to model any engineering system and then will be able to design the controller such that it can automatically control the system. So, this will be the final goal of our automatic control systems lecture. So, coming into the textbook and the references, so I just listed some textbooks here which are very popular and widely used in most of the international universities. However, student can refer to this book or any textbook. Many students, if they have a different textbook, they can read any textbook. So, following a good textbook is good. However, any textbook provides almost similar information. So, if I would like to suggest you, I would recommend to read a couple of books so that you will better be able to understand the concepts. Lecture slides will be provided to you. So, the lecture slides will help you to understand the content, and then students can easily follow the concept. However, if you read a textbook, your knowledge will be much better. We have limited time during our class, so I can't really explain every aspect, so that I will be able to only choose the most important ones. So, reading a textbook is very important if you would like to learn everything about the course. So, there are two references here, the Modern Control Engineering by K. Ogata, which is very popular, and actually the other textbook, Modern Control Systems by R.C. Dorff and Bishop, the Prentice Hall edition, is also very good. So, all these three are very popular. If you refer to any good curriculum, most of them choose one of them. So, you can actually refer to one of the textbook and it should be good enough. Now, moving to the syllabus, I have listed the entire syllabus here, and if you see, the week 1 is divided into 3 parts, P1, P2, P3, and every week is divided into 3 parts. So, each part the title is provided. So, each video session will be corresponding to this one. Now, this is what we are going to do until the midterm. So, from week 1 to week 7 part 2 is the syllabus for your midterm examination. Coming here, I have divided in the other column what we call the first week, we call basics about the control. We learn about the basic information, what is feedback control and what is open loop and closed loop systems in week 1. Once we learn some basic information about what is control and open and closed loop systems, we move on to the block diagrams in the week 2. So, these block diagrams, and later we also review Laplace transform, which is very important because all the modeling is actually done in Laplace domain. Then this is the modeling of physical systems. This is very, very important because in control, if you want to design a controller, first step is to develop the model. A good model can provide a good performance, good control performance. So, developing a good model is very important. So, the modeling is the first step. So, if we have the engineering system, I would like to develop a mathematical model, and from that we can actually represent in terms of block diagrams, which you learn. So, this part is modeling. So, once we develop the model, we can actually know how good it is. So, for that we need to do analysis. So, after modeling, we move on to time domain analysis. So, here we analyze the performance of the system for test signals like step, ramp, parabolic inputs, etc. So, this part until week 5 we focus on time domain analysis. Later on week 6 move on to stability. So, we would like to analyze the system stability in week 6, and week 7 there are two, the first part and the second part focus on review problems. So, the review problems 1, review problems 2 are like tutorial problems where I pick some important concepts and explain the problems related to that. So, week 8 you will have the midterm examination. So, an assignment will be uploaded and the deadline will be somewhere here. So, the information about the assignments will be provided later. So, week 8 you have a midterm examination and that is the syllabus for midterm. So, after the midterm we have the same similar content. So, from week 7 part 3 to week 14 part 3 we have the syllabus for the final exam. So, what we have done is stability before the midterm, after midterm we move to steady state analysis. So, this provides some information about steady state performance, about error dynamics we learn here in week 7 to week 8, week 7 and week 9, and then from week 9 we go into design. The most important of automatic control is in the second part. So, the first part we learn all the fundamental about modeling, about stability, about analysis. Next we are going to design. So, the root locus is both analysis technique and also a design technique. We are going to learn root locus, and then we are going to move into PID controller in week 11, week 12. So, week 11, week 12, this is the most important part, is the PID controller. So, if you ask me, once you learn an automatic control, one thing you would like to do is design the controller. So, every student, once they study the automatic control, this is the final step. After all the analysis of all the thing, you will design a PID controller. So, the PID controller is the important. So, we have like 5 classes, 5 sessions covering from week 11 to week 12 on PID control. Then after the time domain, after everything is done, we move into frequency domain. So, all this analysis we have done is time domain. So, the last part I will actually introduce you to the advantages of frequency domain. So, in frequency domain we actually analyze what is system bandwidth, and also we would like to learn Bode plots for underdamped systems. So, the last part 3 we have review problems and a concluding lecture. So, week 15 finally you have the final exams. So, this is the structure from week 1 to week 15 for your automatic control. So, this is exactly this, each session we have a video session for each one. So, week 15 completes the course. Now, coming to lecture plan, as shown in the syllabus, we have a 15-week schedule, and each week is divided into 3 parts. So, each week you see is divided into P1, P2, P3, P1, P2, P3. So, each week has 3 parts. So, that is about our teaching content. And then most important, grading. So, for grading what we do is we have 2 exams anyway, one is a midterm, one is a final exam, and there is also attendance also. So, combination of midterm and final is around 76%, so it is very important, and then you have attendance around 4%. So, besides that, one important aspect is assignments. If you refer to these assignments, this is a very important part. So, assignment constitutes 20%, 80%, and this is where many students can easily score marks. So, make sure you do the assignments correctly, and moreover for assignments you have a lot of time. Assignments will be given at least 2 weeks. So, the deadline will be, the period will be for 2 weeks. So, students have plenty of time to go to the assignments and try to solve them. So, students have to solve the assignments, and then students have to submit handwritten. So, very important. So, further details I will upload to the website, and most important is there are 2 assignments. One assignment is before the midterm, one assignment after the midterm. So, somewhere in week 4, week 5 assignment 1 will be provided, and then assignment 2 will be provided somewhere in week 12. So, the deadline will be before the midterm for assignment 1, the deadline will be before final exam for assignment 2. So, these 2 assignments will help you to actually analyze all the concepts. Most important in assignments, do not copy from your friends. Assignments have to be handwritten, and you should provide the original copies for me. So, based on this one, the grading will be performed. So, assignments are 20%, midterm 38, final 38, attendance 4%. Now, why are we learning this course? So, the reasons and the objectives of why we learn is we would like to apply our engineering knowledge of mathematics, what you learned earlier, physics, so that we will be able to model and analyze the behavior of systems. So, if I have a Chedongja car, I want to know how the car functions and how we can improve the performance. So, if you want to do that, we should be able to model the car in a mathematical form. So, developing a mathematical framework or a mathematical model is what we call the modeling. Next, our aim is also to design a controller that can satisfy certain requirements. Every system has certain requirements. Every engineering system has a purpose. For example, we have an elevator. Elevator is a lift that actually goes from one floor to one floor. So, there are certain rules the elevator should follow. So, those are like specifications. And students will also learn to analyze the system functions and select appropriate tests to demonstrate. So, you can also learn some testing techniques on how do we test the system performance. So, we will also learn the main aspect we learn is the design techniques such as root locus and PID controller. So, you will also learn what is feedback and the importance of feedback, and we will learn the stability margins for the system in this course. So, what you get in this course is at the end students will be able to model, analyze any real world system, analyze its behavior and then design a controller to modify the behavior and control the system. Now, I would like to introduce what we are going to learn using this system. This is a very popular, the system what we are looking, I call it system. So, we can call a car, this is a normal car. However, if you look at this car, there is some strange extra things. You have some object here and some extra connection. So, this is slightly a modified car. This is our future. This is what we call autonomous car. So, if you look at a normal car, humans control the car. So, what is control? We look at the screen, we look at the window, and then we look if there is any car in front, and we try to maintain the vehicle on the road to maintain speed, constant speed, control the speed, everything. So, we humans try to manually control the car. So, normal car is not an automatic control system. Normal car is a manual control because we drive the car. So, when we drive the car, I look at the scenario, I understand the information and then press the brake, press the accelerator, I actually control the car. So, that is control, means modifying the behavior. What is behavior? When I press the accelerator, car moves faster, what speed the car has to go, less speed, this is what we are trying to do in control. So, when I want my car to be going very fast, then I press my accelerator harder, and when I want to stop, I press the brake. So, this is modifying the behavior. If the system brake does not work, the system cannot be controlled. So, that is the problem with control. Now, if a system is perfectly controlled, we can nicely control the car. So, that is normal traditional car, and Korea is very popular for cars. Kia, Hyundai, we have so many cars, good manufacturing cars, high quality cars, very popular in the world. Many countries use Korean cars. Now, what we are looking here is an autonomous car. So, what is the difference compared to a normal car? Autonomous car does not require a person to drive the car. So, that is in future. We have now semi-autonomous cars, and many companies are now testing autonomous cars. They are almost done. Even Hyundai has parking assist, self-parking, half semi-autonomous functions in the current generation cars. I think in the next 5 to 10 years, we will be seeing everything autonomous cars. Now, what is difference is when you drive the car, you decide what to do. Humans, persons will decide whether to go forward, whether to go backward. Next, an autonomous car automatically does it. So, an autonomous car is of our interest because that is our automatic control system. So, the difference between a normal car and an autonomous car is the sensors. The system is different. For an autonomous car, you need a video camera, you need a lidar, some kind of radar, GPS, another radar sensor here, and then we have an ultrasonic sensor here to actually measure the wheel, and then we have radar center in front to see any collision detection, object detection, everything. So, all these sensors try to understand the environment around you, and then try to form a decision. So, the onboard computer processes all this information and then decides whether the car can move, whether the car can go left, right, what is the direction. The GPS will provide which way the car has to drive. All this information process is important. So, a system has to process all this information and then decide the controller. So, for an automatic control system, it has to analyze the information, the environment by itself. So, we need all the sensors that can provide all the useful information, and then the car can decide itself whether to go, whether to brake, whether to accelerate. All this decision the car can take. So, if I try to present you in a form of a diagram, this is what we call a simple block representation, control system representation. So, we'll learn this representation in the later classes. So, what is here is how the information flow occurs. The first step is called what we call requirement. The rules is lane detection, decide speed, avoid collision. So, the basic rules, that means you will decide what are the rules, never hit anyone, right. So, and then the control action, the car can do the steering, acceleration, braking, some function. There are so many, but I just list a few of them. And then once you provide to the input, car will move, and then you have to get all the data. What is the speed of the car? What is the radar sensor? All this information we call sensors. All the information from the sensors we get into the system, then we make a decision whether to go or far. So, if there is an object detected, then the car has to stop. So, this kind of information is very important. This is how the control is done. So, then this path is called forward path, and this path is called reverse path, because once the system moves, the car moves, we try to see what is the change in the environment and try to gather the information. So, this kind of loop where we constantly give input to the system and then measure the output, try to get the feedback, this is exactly what we call the control, a feedback control. So, if we try to analyze what is control, it is to change the behavior of the system to obtain desired output by performance. So, we try to modify the system behavior so that we can get our desired performance. What is control engineering? Is goal to control complex dynamic systems. So, real engineering systems like a sports car, train, we would like to control. Now, what is control is action on the system like an aircraft car to change or improve its behavior according to desired performance. So, we list the rules, what is performance, and then we try to control so that we can achieve that performance. So, this is very basic information. We will discuss in detail in the next class, that is what is control engineering. So, I would like to just introduce you in this class. Now, the most important. So, what is the best learning method is, in the lecture, I would like to give you all the information about the theory. So, the first part I will do is I will present you the theory, and then for the I will give you the PPT. So, the theoretical aspect students can actually learn from the textbook, and I will be teaching every part of the theory. Next, theory you can always learn from the textbook, you can read yourself, whatever. Theory part at least is easy. Now, most important is this is not a science, or this is not just a theoretical subject. Automatic control is a practical design lecture. That means every system we are going to use, or every system we model, are real systems that is present in the world. So, I want students to actually start looking engineering systems differently. When you look at a car, try to understand what are the requirements, what is performance. So, the most important is application. Once you learn in the classroom, I want students to apply these concepts to real world. So, you can just think what is the requirement, what is the KTX, what speed, what components it has. So, just try to understand the real system. If you understand the functions, then you can also understand how we can apply. So, the application is most important. So, if you solve a lot of questions, means we are applying theory to real problems. So, link theory to application, this is the most important. If you link theory to application, you can understand better. So, if you understand better, your concept will be really good. So, to understand much better, you should always link between theory and application. So, you understand a theory, then apply, try to understand application, then you try to improve your understanding. So, since this is a design course, we should always study theory and its application. So, most students spend solving a lot of questions, so they understand the theory, they apply. But a lot of real problems of a system we can only understand when we really do it. So, the other thing we can do is, the third part for the implementation is how do we design this and apply on a real system. We have good software tools such as MATLAB or a GUI interface like Simulink, which can provide control models, and you can play with the system, you can better understand. So, if you follow all these 3 steps and try to understand the theory together with the application, and if you are able to implement, then it completes your understanding. So, the objective of learning is to get the knowledge. It is not about getting A+ grade, but I want the students to really learn the concepts well. So, learning a concept means you should be able to apply the concept to any system, understand the problems, nuances with the system, and then solve the issues related to the application. And then if you are able to implement, then your learning is complete. This is the level that is required. Once you graduate engineering, when you go to any industry, and if you want to be a control engineer, which is a very good job, then you should be able to understand everything. So, students, don't just study textbook, please also analyze every application you see and try to understand. So, in the whole course, I will spend a lot of time on explaining the connection between theory and application. So, every example I try to give a real system and then try to apply the theory. So, this is very important, and I want the students to actually work on this. Next, if you have any queries from the lecture, since this is an online lecture, I believe students cannot have a one-to-one interaction, but students can meet me in person. I will try to schedule a time every week, and students can freely visit me and try to clarify any questions related to the lecture. So, the information I will provide on the S website. So, you can please refer to the S website for this time, and then you can actually visit my office during that time. The other thing is, if you are unable to visit during the time, you can try to send me an email if you have questions, and also schedule an appointment. So, please refer to the website and try to contact me and send me any suggestions or any issues you have related to the course. Now, as I suggested, learning cannot be limited to classroom. I do not believe learning is just the lecture, PPT and our interaction. You can learn anywhere. You can learn outside the class, you can learn on the internet. So, you have internet, which is one of the best thing to gather information. So, you can actually refer to any courseware. In that aspect, you have so many resources on the internet. I just listed a few of them, where you can actually go through so many examples, and then there are also open courseware from MIT, where they provide all the courses related to electrical and electronics engineering. You can actually find automatic control, not only automatic, but you can refer to many course structures and materials, even online videos here. So, this will be really helpful. So, these kind of resources can be very helpful to solve any questions and also improve your understanding. So, this will be the end of our lecture. So, in the next class, we will actually start with the real control. So, the first part is what is control, and then we will also understand, we will try to learn what is feedback control systems. So, I would like to thank you for choosing this lecture, and then we will continue with what is control in the next class. So, thank you for this lecture, and this is the end of week 1 part 1. 감사합니다.